Hello everyone. We're starting a free open lecture in our Discord channel. All our lectures are held daily without breaks. If you're a viewer and want to ask questions and get answers in an online format, then join our lectures. You can find the link to Discord in our Telegram channel. To find out the time of the lecture, join our Telegram channel and Discord. Let's move on to the plan in the chat. 2 seconds, 512 megabytes. You're just an ordinary chat user. You want to send a triangle of emojis in the chat that is size K. Such a triangle consists of K1 messages. Well, here it is. The first message consists of 1, the second one has 2, writing from K. So, the triangle with K equal to 3 consists of 5 messages. And the third one consists of 3 emojis. Yeah, and the subsequent ones actually decrease. That's it? Here, well, the picture mostly explains it. Of course, most channels have moderation, including automated and manual systems. The moderator, who could be a person or a bot, will ban you after you send XAML in a row. Now we know how many messages we can send before you get banned. And being banned means you won't be able to participate in the chat. Or maybe they won't ban you at all. Maybe we'll send all the messages there without any issues, complications, and difficulties. And yeah, also note that if you get banned after sending a certain message, that message is counted too. So if we get banned because we sent, let's say, the 7th emoji, we'll still send 8. We just won't send the 9th one. You need to respond to t-independent sets of test data. Well, t is 14 with some additional information. And this time we have no guarantees that our count doesn't exceed. So now t is a significant number. Let's write down that t is 10 to the power of 4. So the only line of the test data set contains 2 numbers, k and x. K is the size of the triangle in the chat that we want to send, up to 10 to the power of 9, and x goes up to 10 to the power of 18. Yes, yes, up to 10 to the power of 18. What we need to find out. The number of messages you can send before you get banned. Actually, well, at Cakes, well, here is a direct analysis of examples. So we want to build a triangle of size 4, which means, well, and also down. X is from 6, meaning after 6 emojis, we get banned. In the first case, we end up sending 3 lines. Why? Because we send the first message, the second message, and the third message, which consist of 1, 2, and 3 emojis, respectively. Their sum equals 6, which is greater than or equal to 6, so we get banned. In the second case, we have exactly the same conditions, but after 7, and we conclude that we will send 4 messages because that's how many we need. Because by sending the 4th line, we will exceed the limit and get banned, but the 4th line will still go through. Well, there are already spoilers on the right, but I can't do anything about it, and it's solved. Because by sending the 4th line, we will exceed the limit and get banned, but the 4th line will be sent. Well, you know, there are spoilers on the right, but unfortunately, I can't do anything at this particular moment, and it's solved. So, how are we going to solve this problem? First of all, let us consider what exactly are our emoji triangles and why they are important. This is a progression. What kind of progression is this? It's arithmetic, obviously. So here's the thing. Well, actually, we can immediately and efficiently determine and calculate, for instance, how much this piece surpasses or exceeds our limit, or if it doesn't exceed it in any way. If it doesn't exceed, then of course, we need to carefully check this specific part first. Will this piece exceed it then? If not, then it's clear that we logically conclude with certainty we've sent 2K1 messages, because that's how it will be. If in one of the cases we exceed either here or there, we start searching. How are we going to search? It's clear that it was already mentioned how we will search, but I still want to hear about it using binary search. So what are we going to do? How are we going to use this binary search? But to be more precise, it's probably even somewhat of an upper bound. It's not just a binary search, but you can see there's a difference. They have the minimum, yes, the message. So how is it going to look for us then? It's clear that we'll check how many messages we're going to send. How is it going to look for us from 1? We have here the formula 1 plus some k. The value of k is essentially not very favorable. We have this number called k. That's fundamentally considered as an incorrect approach plus t. So it turns out multiplied by t, everything green, by 2. Right. Next, it should be less than or equal to, let's say, less than or equal to our x or delta x. Well, t is actually what we will be iterating through with binary search. It's kind of our mid. So t will be in the first case if we're stuck here, floundering from 1 to k, and in the case, if we're stuck here from k plus 1 to 2k1, and here it will look obviously in reverse progression, so here it will be k1 plus our t multiplied by k1t. Ideally, there might not be a minus 1 here. We need to double check that. The difference is just, well, that's it, really. So if we're stuck here, we use binary search to find it. The binary search finds it for us. Well, I mean, technically it's not exactly binary search. It's an upper bound, so we need to find the next one after the suitable one. If it's not equal to it, well, that's fine. That can be done too. Just add one more if down below, and that's it. So if we're stuck here, we use this kind of bound. And then we just output our resulting t where we will stop. Overall, that's it. There's nothing more to do here. And it's actually 1300. You really just need to calculate it without searching. This is a very old problem of mine, so there's a lot of junk code, even more than usual, but I've already explained what's happening, so I don't know. Here, the cat won't help. It's really scary. Actually, if you don't look at that solution, it was probably solved more or less the same way, just more awkwardly. We just use two binary searches, depending on the case. We check if we fall into this triangle. Actually, if you don't look at that solution, it was probably solved more or less the same way, just in a more awkward manner. We just use two binary searches, depending on the case. We check if we fall into this triangle. If we pass through it, then we, well, obviously subtract the sum in this triangle, sum s from our x, so xs. We have dx, this remaining one, and we're calculating exactly in dx now, right here, where we will stop with this binary search. If we stop here, we just use this condition. That's it.
Want to become a great programmer? Subscribe to our Telegram channel.